Today objective is, on the completion of this topic you would be able to know solve the problem on electric stored in magnetic field, electric energy stored in magnetic field. So you know that the formula for what is the expression for the energy stored in an inductor, that is equal to energy stored in an inductor is equal to E equal to half Li square joules. So where the E is equal to energy stored in joules and L is the inductance in Henry and I is equal to current in amperes. The I is equal to current in amperes. So here the energy stored in inductance, the energy stored in inductors, half Li square, here E is the energy stored in joules, the L is the inductance in Henry and I is the current in amperes. So this is the expression for energy stored in an inductors, the energy stored in an inductors. So on this expression we have to some problem we have to solve. So first problem is nothing but an air core solenoid 1.5 meter long and 15 centimeter in diameter has 75,000 tons of conductor. Calculate the energy stored in an magnetic field when a current of 2 ampere is flows. Okay na. So a solenoid conductor has 7500 tons conductor is there on solenoid, air core solenoid. So the solenoid length is nothing but 1.5 meter long. So here the diameter is given. The diameter is nothing but 15 centimeter. So calculate the energy stored in magnetic field when a current of 2 ampere is flowing. So here the given data is nothing but the length of the conductor, that is the L. The length of the conductor, it is the length of the conductor L is equal to 1.5 meter. Next, the diameter of the solenoid is given. The diameter is nothing but the 15 centimeter, which is equal to it is converted in the meters. Here the length is the in meter is there. The length is given in meter, and here the diameter also we have to convert in the centimeter to meter. So here the diameter is nothing but 15 centimeter, which is equal to 0.15 meter, meters. So where number of turns, number of coils, number of conductor, which is equal to 7500, and the current flowing through the solenoid conductor, is equal to 2 amperes. So here the air core solenoid. So here the relative permeability value is equal to 1, and absolute permeability value, that is the constant parameter. So here the 45 into 24 of minus 7, So here, so from the formula we know the relation. Is nothing but the energy stored in magnetic field is equal to E equal to Li square. So here the length is given, I is given. So then we will find the directly the length, inductors, that is the inductor, L equal to inductors, L is the inductor here. So first we have to calculate the value of inductance value, L value we have to calculate. So what are the relation between the inductance and current and area of cross section? Area of cross section. So we know that the relation between the area of cross section and current flowing through the conductor and length of the and inductance of the conductor, inductance of the solenoid conductor is equal to L equal to mu naught into mu r into n square into a by I. Okay, now so this expression we will get from the relation in the expression for inductance, mutual inductance and self inductance, then we will get the inductance value L is equal to absolute permeability into relative permeability into n square into a by I, n square into a by I. So here the a value is not given, only diameter value is given. Diameter is equal to 0.15 meters. So then we have to find the area of cross section. A is equal to pi into d square by 4, pi into d square by 4. So we have to substitute the value of d value in this equation, then we will get a value is equal to pi into d value equal to 0.15 square by 4 by 4. So 176.7 into 10 to the power of minus 4 meter square. 176.7 into 10 to the power of minus 4 into meter square. So this is the value for A. This is the value for area of cross section. Next, we have to calculate the value of L. L is equal to mu naught value is equal to 4.24 of minus 7. Mu r value relative permeability, mu naught equal to absolute permeability, mu r value equal to relative permeability value equal to 1 into number of turns n square, n is equal to 7500 square. Next, so here area of cross section is equal to 176.7 into 24 minus 4 by 1.5 by 1.5, that is the length, so which is equal to 0.833 Henry, that is the inductance value. Then energy stored in the magnetic field E is equal to half Li square, so half into 0.833 into 2 into 2, which is equal to 1.66 joules. So this is the energy stored in inductance. So this is the first problem. Next, second problem. A four pole 400 volts shunt motor has field resistance of 400 ohms and a flux of 0.025 Weber per poles. Calculate the energy stored. If each field coil has 1200 tons. So from the second problem, you have to observe the given data. The number of poles is equal to 4. Next, voltage V is equal to 400 volts. Voltage V equal to 400 volts is given. Next, the number of turns is equal to 1200. Next, the current flowing through the conductor, motor is equal to 2 amperes. 2 amperes is given. So the resistance of the motor resistance is equal to 400 ohms. And the flux per pole equal to 0.025 Weber. Weber. Then the formula, okay na, the formula for the relation between the inductance and the length and number of turns and the flux, which is equal to L is equal to N into pi, N into pi, N into pi by I, N into pi by I, and energy stored in the magnetic field E is equal to half Li square, half Li square. So here the pi is equal to 4 into 10 to the power of 4 into 10 to the power of 0.25. Why? Because here the 4 pole is there and flux per pole is equal to 4 into 0.025, which is equal to 0.1 Weber, which is equal to 0.1 Weber. So here the current flowing through the conductor, the current flowing through the motor, which is equal to V by R. So here the V is given, the 400 volts, and resistance is given, that is the 400 ohms. So that is the 1 amperes. Next, the L is equal to N into N is given 200 turns into 0.1 by 1, which is equal to 120 Henry. 120 Henry. This is the L value. This is the L value. That is the inductance of the motor. Inductance of the motor, which is equal to L is equal to N into pi by I, where N is the number of turns, where N is the number of turns, where is the number of turns is equal to 1200 turns into flux is equal to 0.1 by 1 ampere current, 1 ampere current. Then the inductance of the shunt motor is equal to 120 Henry, 120 Henry. Next, the energy stored in magnetic field, energy stored in magnetic field, half Li square, where L is the inductance of the motor. So that is the 120 into I square equal to 1 ampere. So 1 square. So half 120 means the 60 joules. That is the energy stored in magnetic field is equal to 60 joules. 60 joules. So this is the second problem. You have to calculate the value of energy stored of each field coil has 200 turns. Here in this problem the current is not given. Current you have to calculate the relation between the Ohm's law, relation of between the Ohm's law. So V by R. So here in the given data I equal to 2 ampere is the, that is the wrong. So here the current value is not given. So we have to find the value of current equal to V by R, that is the voltage by resistance, that is the 400 by 400 equal to 1 ampere. Okay, now we have to calculate the value of I value and L value. Then we will get the energy stored in magnetic field, E equal to half Li square. So half into 120 into 1 square equal to 60 joules. 60 joules. So this is the value for energy stored in the magnetic field of DC shunt motor. Next, third problem. Third problem is equal to an air core solenoid. An air core solenoid has 0.5 meter long, 500 centimeter in diameter, and it has number of coil is equal to 1000 tons. Calculate the energy stored in the magnetic field. When a current of 5 ampere is flowing. Okay now. So here the length of the conductor equal to 0.5 meter. The length of the conductor is equal to here 0.5 meter. This is the length of the conductor is given, and the diameter of the air core solenoid is 5 centimeter. So here the centimeter to meter is converted. Then we will get 0.05 meter. meter. The number of turns is equal to 1000 turns. Number of turns equal to 1000 turns. Next, the current flowing through the solenoid conductor I is equal to 5 amperes. I is equal to 5 amperes. So the air core solenoid here, the solenoid is nothing but air core. So the relative permeability value is equal to 1. Relative permeability value equal to 1. So from this problem, we have to find the value of energy stored in magnetic field. Energy stored in the magnetic field. What is the formula for energy stored in magnetic field? E is equal to half Li square. Where L is the inductance of the solenoid conductors and I is the current flowing. So here I is given, but the inductance of the air core solenoid is not given. So first we have to find the value of inductance. So L, okay now. So what are the relation between the L and area of cross section and length of the conductor, which is equal to L is equal to absolute permeability into relative permeability into number of turns square into area of cross section by length of the conductor. That is the mu naught into mu r into n square into A by L. So here we know the value for absolute permeability. Mu naught value equal to 4 pi into 10 to the power of minus 7, and we know the value of relative permeability value mu r equal to 1. Why? Because here the solenoid conductor are placed in the air. Solenoid conductor have to placed in air. Next, the number of coil is given, that is the n value equal to 100 turns. Next, the area of cross section A is equal to pi into d square by 4, where d equal to diameter of the air core solenoid. So where d is equal to 0.05 meter, g equal to 0.05 meter. So here the pi into 0.05 meter square into by 4. So the area of cross section is equal to 19.63 into 10 to the power of minus 4 meter square. So here the A value will be substituted in the inductance value. Then the L is equal to mu naught into mu r into n square into A by L. So here 0.5. Then we will get the inductance value. Inductance value is equal to 0.005 Henry. So the energy stored in the magnetic field, is equal to half Li square. So here 1.1 by 2 into half into 0.005 into 5 into 5. That is the I square. Then we will get the energy stored in the magnetic field. The energy stored in the magnetic field is equal to 0.0625 joules. So this is the energy stored in the magnetic field. So this is the third problem. Next, fourth problem. A current of 20 milliampere is passed through a coil of self inductance 500 millihenry. Find the magnetic energy stored. If the current is halved. Find the new value of energy stored. And the energy is released back to the electrical circuit. Back to the circuit. Okay, this is our problem. So What is the problem here? A current of 20 milliampere is passing through a coil of self-inductance. Coil of self-inductance is the 500 millihenry. 500 millihenry. Find the magnetic energy stored. Find the magnetic energy stored. If the current is halved, find the new value of energy stored. Find the new value of energy stored, and the energy is released back to the all electrical circuits. Back to the electrical circuits. So here first we have to observe the given data. Okay, now what is the current is given? The current is given. That is the current is the 20 milliampere. Current is the 20 milliampere, and the inductance value is equal to 500 millihenry. 500 millihenry, and what is the what we can find out? The energy stored in the magnetic field. Energy stored in magnetic field, that is equal to E is equal to half Li square. E is equal to half Li square. E is equal to half Li square. So here, where L is the inductance value, and I is the current flowing. So the energy stored in when the current of 20 milliamperes, the E1 value. If the current is the half, next case the current is half, that means the current value equal to 10 milliampere. Then the current value equal to 10 milliampere. So here the E2 is equal to half Li square. So what is the energy released back to the circuit? What is the energy is released back to the circuit is, that is the E1 minus E2. So here first we have to find the value of E1 value. Okay now, when the current is the 20 milliampere is flowing through the circuits. Okay now, so the energy stored when the current is flowing, that is the 20 milliampere. So the E1 is equal to half Li square. So half Li square is equal to half into, where L is the 500 millihenry. So 500 into 24 of minus 3. 500 into 24 of minus 3 into current equal to 20 into minus 3. 20 milliamperes. So then we will 20 into minus 3 square. Then we will get the energy stored when a current of 20 milliampere is equal to 100 into 24 of minus 6 joules. 100 into 24 of minus 6 joules. Next the magnetic, this electrical energy stored in the magnetic field when the current is the half. That is the half means the 20 milliamperes to the 10 milliamperes. 20 milliamperes to the 10 milliamperes. Then we will get the energy stored in the magnetic field. E2 value is nothing but half Li square, where L is, okay now, where L is the 500 into 24 of minus 3 into 10 into 24 of minus 3 square. 10 into 24 of minus 3 square. Then the E2 value equal to 25 into 24 of minus 6 joule. 25 into 24 of minus 6 joules. So this is the E2 value. Then the new energy is released back to the circuit is E1 minus E2. E2 is equal to 100 minus 25 into 24 of minus 6. 100 minus 25 into 24 of minus 6 is equal to 75 into 24 of minus 6 joule. 75 into 24 of minus 6 into 6 joules. So this is our fourth problem. Next problem. The field winding of a machine consists of 8 coils. The field winding of a machine consists of 8 coils in series. Each contains 1200 turns. Each contain 1200 turns. When the current is 3 amperes, the flux linked with each coil is 20 milliweber. Each coil is 20 milliweber. Calculate the energy stored in the circuit. So here once again we have to read the problem. A field winding of machine consists of 8 coils. 8 coil is there. The field winding of machine has 8 coils is there in the series. The coils are in series. Each winding will be contains 200 turns. So here number of turns is there, that is the 1200. N is equal to 1200 turns. So here coil equal to 8 coils is there. So 8 coils into 1200. 8 coils into 1200. 8 coils. So here then when the current is 3 amperes, the flux linking is each coil is a 10 milliweber. Calculate the energy stored in the circuit. So here first we have to calculate the value of I. I value is equal to V by R. Next, the energy stored in the magnetic field. So here the half Li square. The L value is nothing but N into pi by I. The relation between the flux and number of turns and the current flowing through the conductor So the L is equal to N into pi by I, where N is the number of turns, that is 200 turns, into flux, that is a flux is the 20 into 10 to minus 3 Weber by 3 amperes, that is the, then we will get the inductance of the coil is equal to 8 Henry. The total inductance how much? The 8 coils is there. The 8 coils into inductance. So 8 into 8 equal to 64 Henry. That is the total inductance of the machines. Total inductance of the field winding. Field winding has 8 coils is there. Each coil contain 1200 turns. So then we have to calculate the value of total inductance of the each coil. Total inductance of the all coil. Then we will get 8 into 8, that is 64 Henry. So the E is equal to the energy stored in the magnetic field. E is equal to half Li square. So half into 64 into 3 square. Then we will get 288 joules. So this is the energy stored in the magnetic field. Value. So we have to learn about the problems on energy stored in magnetic field. So that which is equal to so here the relation of the L is equal to N into pi by I, and L is equal to mu naught into mu r into N square into A by L, and the equation for energy stored in the inductance is equal to E equal to half Li square. So the E equal to half Li square. On this relation we have to solve the problems. Some quiz question given here. The formula for induction of a coil. Inductance of the coil. Inductance of the coil. So which is equal to, here three formula is given here. L equal to n square into mu naught into mu r into a by L. L is equal to L into n square by mu naught into mu r into a, and L is equal to n square into L into mu naught into mu r into by a. So here the first option is the correct answer, but here given the capital L value also, that where L is the length of the conductor. So the first option is the correct answer. N square into mu naught into mu r into a by L, where L is the length of the conductor. Here the capital L equal to inductance of the coil. Next, second question. The energy stored in a magnetic field. The energy stored in a magnetic field. The energy stored in a magnetic field. So which is equal to, the E is equal to half Li square joules. Half Li square joules. So here the first option is the correct answer. Second option is nothing but the E is equal to half Lv square by joules. So this is not correct answer. Next, the E is equal to half Cv square. So this is the half Cv square is nothing but the energy stored in capacitance. The energy stored in the capacitance. So here the first option is the correct answer. Half Li square. The E is equal to half Li square. E is equal to half Li square. So this is the our some huge questions and expressions. So from frequently absolute problem is given. We have to just read it and solve it. You have to read it and solve it. Then we will get easily understand problems on the energy stored in magnetic field. Energy stored in magnetic field. Okay. Thank you.